Good evening, friend. Study with Apala इंजीनियरिंग एंड जर्नल जियोलॉजी परवीन से बुक। तो हम लोग चैप्टर 13 पढ़ रहे हैं जो कि इग्नियस एंड रॉक के बाद है। रॉक में हम जानते हैं 3 मेजर तरह की रॉक होती हैं, इग्नियस, मेटामॉर्फिक एंड सेडिमेंट्री। और सेडिमेंट्री रॉक मॉडिफाइड भी हो जाती है और अगर ओसिन में बन रही है तो अर्थ पे भी बन रही है, कॉन्टिनेंट वगैरह से। तो अब टेक्सचर ऑफ सेडिमेंट्री रॉक पढ़ेंगे टॉपिक। उसका नेक्स्ट टॉपिक है जस्ट वेट। सेडिमेंट्री रॉक्स so considerable variation in their textures or mutual relationship of the constituent minerals. Their texture is determined by at least 6 contributing factors. And so origin of grains, sedimentary rocks may be partially or woolly is composed of clastic or allogenic grains or of chemically formed or organically contributed parts, and thus the rock may show a clastic textures or non-clastic textures. Size of grains. The grain size in the sedimentary rocks varies within wide limits. Individual grains of less than 0.002 millimeters or more than 250 millimeters may forms a part or wholes of these rocks. 3 texture recognized on the basis of the grain size are coarse grained rock and average grain size greater than 5 millimeter, and medium grain rock average grain size between 5 millimeter to 1 millimeter. Fine grains rocks average grain size less than 1 millimeter. Shape of grains. The sediments making the rocks may be of various shapes, rounded, sub-rounded, angular or subangular, and they may show sphericity to various degrees. Roundness and sphericities are the indications of varying degree of transport and aberrations suffered during that process, and thus breccias are made up mostly of rough and angular fragments indicating least transport and aberrations. Conglomerates are full of rounded and smooth surface pebbles, and gravels indicating a lot of transport and rubbing action during their transport before getting deposited and consolidated into a rock mass. Packing of grains and sedimentary rock may be open packed or porous in textures, or densely packed depending upon their environment of formations. The degree of packing generally is related to the load of the overlying sediments during the process of deposition. So fabric of grains are given sedimentary rocks may contains many elongated particles, and their orientations is studied and described in terms of orientations of there's longer axis. Most of the elongated particles are arranged in such a ways that their longer axis lies in the same general direction. So the rock is said to show a high degree of preferred orientation. The direction is generally indicative of the direction of flows of the current during the period of depositions. So crystallization trends in sedimentary rocks of chemical, organic, and the textures is generally and so defined by the degree and nature of crystallized grains, and rock may show the perfect interlockings, grains giving rise to crystalline granular structures, so they may be made up of non-crystalline colloidals and particles when they are termed as amorphous, and the structure of sedimentary rock. The term structure signifies some large-scale features developed in the rock's masses during the process of their formation. These can be studied under the following 3 headings. Mechanical structures. These are the most prevalent and the structures of clastic groups of sedimentary rocks, and they are developed due to physical process operating at the time of depositions of the sediments. And followings are common mechanically developed structures of sedimentary rocks. Stratifications, by stratifications is understood a layered arrangement in a sedimentary rocks. This may be developed very prominently and can be seen from a distance of miles, or in other cases may have to be ascertained after close examination of the rock. The different layers, also called beds or strata, may be similar or dissimilar in color, composition, grain size, and texture. And planes of weakness, and so the bedding planes separate the beds from each other. The thickness of each layer in a sedimentary formation may show great variations from a few centimeters to many meters in lateral extensions. The layered structures may show continuities for several meters to hundreds of kilometers. So further, the layers may be horizontal or slightly inclined when they are undisturbed after their formation. In other cases, they be steeply inclined, folded or bent or broken or overturned if affected by tectonic factors after their original depositions. Stratification bed, and this is most important picture, so please make a diagrams with labeling. Give you more mark. Examinations. This is also a layered structure similar to stratifications as found in the sedimentary rocks. In laminations, however, the individual layers are quite thin, generally is less than 1 centimeter in thickness. Laminations is a characteristic structure of fine-grained sedimentary rocks like clays and shell. The individual layers are called laminates and are distinguished commonly on the basis of difference in color. So cross bedding, it is a sedimentary structure in which various layers lying one above and others are not parallel but bear an irregular or inclined relationship to each other, and such structures often result from depositions having take place in a shallow water environment. In such environment, the streams suffers a repeated change in directions of flows or the current product in the bodies of the water. The such structures is sometimes referred as false beddings or current beddings. Following are common types of false beddings. Tabular. Tabulars are types of rock cross beddings in which the top and bottom surface of the deposits are essentially parallel, indicating its deposition in the same main channels, but the intervening layers are inclined differently with respect to each other. Lenticulars are types of cross beddings in which also the layers show an extreme irregularities in their shapes and dispositions. Each individual layers may be intersected by many other layerings at different angles. Bedding wedge. W is silent, H is shaped. So in this case, the cross bedding structure is highly complex. The individual layers exist in which well-defined sets of parallel layers, but these sets bear angular relationships to each other. These layers set as are sometimes mutually inclined in such a way that this gives the appearance of interwound and edge when seen in the vertical cross sections. So figure A, B, C. So here C is this. Edge means corner. So graded bedding. In some stratified rocks, the component sediments in each layers appears to be characteristically sorted and arranged according to their grain size, the coarse set being placed at the bottoms and the finest at the tops, and such an individual layer is said to be graded. And so when a sequence of rocks is made of such graded layers, the structure is called graded beddings. And normally such a perfectly is a graded bed are the result of sedimentations is in bodies of standings, water, severe factors of gravitative settlings from a mixed load is the prominent process in many cases. However, the exact cause of graded bedding is far from simple and may be attributed to such unrelated process as subaqueous landslides and submarine earthquakes. Mud cracks. These are common structural features of many fine-grained sedimentary rocks. The structures consist of polygonal or irregular cracks spread along the surface of an exposed sedimentary layers. Their development is explained by an analogies of development of similar cracks on the surface of drying mud in shallow environment even at present. Once these cracks are covered under further layers of muds, and they get preserved in the body of the deposits, and they comes to light once again once the overlying layers are eroded with the passage of time. So paints print. Rain print. So these are regular small craters and shaped depressions seen on fine-grained dried sediments. Like mud cracks, their formations can also be explained on the analogy of present-day process. Rain falling forcefully on the fine-grained compacted clays and softens make crater-like depressions. These may get dried up and subsequently is preserved under another layer of mud, and so the imprints becomes a part of the deposits. Ripple mark. These are also quite common types of sedimentary structure of mechanical origins and found in deposits and made in shallow water environment. They are defined as symmetrical or symmetrical wave-like undulations or irregularities in a layer. Ripple mark generally result from interplay of wind actions and waves action during the process of deposition. The direction of a shallow water's current can easily be affected by strong winds blowing over the current, and the fine sediments get dragged along with the current because of the waves generated and deposited as and where the waves becomes weaker and others change in the direction of the current would create another layers of deposits in opposite direction, and so on. The mud cracks, rain prints, and the ripples marks when encountered in sedimentary formations are taken as a confirmatory evidence of the formation having been deposited in a shallow water environment. Thank you.